In this video, I'll walk you through a technique called a classification tree. A classification tree is a predictive analytics technique which is very useful when you have the following situation. You want to predict something about an item. Let's say your item is a student, and you want to predict whether or not the student will have a job offer upon graduation. You know some information about your item. For example, with the student, you know the student's university, major, GPA, and how many letters of recommendation were written for this student. And the known information is not all the same. By this, I mean GPA is measured on a 4-point scale, but the university name is a text field. So numbers and text aren't the same. Let's take a look at our student data set. The thing we want to predict, whether the student was hired or not, is our target variable. Everything else, school name, major, GPA, and number of letters of recommendation, gets listed as an independent variable. Here's what the classification tree algorithm does. First, it starts with our entire data set. It lines up our independent variables, and one by one asks the computer, if we only use this variable, how well would it predict whether or not a student was hired? We ask, if we only use the name of the school, how well would that predict hiring of the student? It answers, a medium amount. We ask, if we only use the student's major, how well would that predict the hiring of the student? It answers, a medium amount. We ask, if we only use the student's GPA, how well would that predict hiring of a student? It answers, a lot. It says you get the best differentiation at a GPA of 3.0. Those above it tend to get hired, those below do not. If we only use the number of letters of recommendation, how well would that predict the hiring of the student? It answers, not at all. I've got to stop asking here because I've run out of independent variables. From this series of queries, we have two really useful bits of information now. First, that the best predictor of hiring is GPA. And second, that the cutoff is a GPA of 3.0. It told us what to cut and where to cut it. So now the computer will start building a tree, like this. Now we know that the single most important piece of information that predicts the hiring of a student upon graduation is the GPA. We then ask the computer, are you done, or can you branch out a little more? It says it wants to try a little bit more. So we focus first on the left-hand branch. Now, we are only going to consider the students who fit this criteria, those with a GPA at 3.0 or higher. The algorithm lines up our independent variables, and one by one asks the computer, if we only use this variable, how well would it predict whether or not a student was hired? We ask, if we only use the name of the school for everybody with a GPA of 3.0 or better, how well would that predict hiring of the student? It says a medium amount. We ask, if we only use the student's major for everybody with a GPA of 3.0 or better, how well would that predict the hiring of the student? It says a lot. You get the best differentiation if you group the majors as business, computer science, and operations management in one high likelihood grouping, and everything else, math, English, biology, etc., in the other low likelihood grouping. We ask, if we only use the student's GPA for everybody with a GPA of 3.0 or better, how well would that predict hiring of the student? It says, not much. Everybody here is above a 3.0, and there's nothing much to be gained by differentiating 3.0 from 3.5. If we only use the number of letters of recommendation for everybody with a GPA of 3.0 or better, how well would that predict the hiring of the student? It says, not at all. I stop asking here because I've run out of independent variables. This tells us what our next split should be. We should split the left-hand GPA node on the student's major. We then take our focus down to node 4. This is everybody who has a GPA of 3.0 or greater and who has a major in business, computer science, and operations management. We ask the algorithm, Let's do it all again. It tells us it can't find anything more useful. We mark this leaf as a terminal leaf and say we can't break this category down anymore. You probably get the general feeling of what we're going to do now. For each node in the tree, we're going to go back to it and ask it, can we split you, or are you a terminal leaf? Our complete tree emerges. I've noted the percentages of the nodes on there and the size of each node. Now let's look at what each node in this tree is telling us. You could see at the top here, we have a designation, which is hired. That tells us most of the people in this node are hired. Next, we have a percentage split. This tells us that everyone in this node, 93% of them are hired, but 7% aren't. Remember, to get into this node, you needed a GPA of 3.0 or higher and a certain major. An unlucky 7% of students with these qualifications still didn't get a job offer in our data set. And finally, we have a head count. This tells us it's a relatively big node. 38% of our data set is here. And that is how we build and read a classification tree. To recap, we start with the target variable, what we want to predict. In this case, was the student hired? We also need to start with many independent variables, what we already know, in this case, GPA, major, and some other information. We start our tree with bucket 1, which contains everybody. The algorithm runs all the independent variables past it, asking which one gives the best differentiation between those who were hired and those who were not hired. It picks the winner. Now we know on which variable to split and at what level. For our tree, this was GPA and at 3.0. It then continues to iterate through each node on the tree, trying to split it on our independent variables, and stops when no further splits will give any improvement in classification. You can then use this classification tree as a black box model to make predictions. You could take a new student, apply the tree to the new student's information, and make a prediction about whether the student will be hired or not. Thank you for watching. Now you've seen a classification tree.